To prepare for the final, we have a practice test. The first we have is Learning Target 6.1. I can use Avogadro's number, which is 6.02 times 10 to the 23rd, and moles to calculate chemical quantities. We may also be using 22.4 liters per mole of gas at STP. We will give you these values on the final. So first question, what is the molar mass of iron 3 chloride? So first, to find iron 3 chloride, I have to figure out what the formula is. I know iron is Fe. So Fe, and I know it's going to be 3 plus. Chloride, the halogen, it is Cl minus. In order to be neutral, I need 1 iron and 3 chlorines. So 1 iron is 55.85. And I need 3 chlorines, that's 3 times 35.45. And so what I would do is on my calculator, I would do that first, 3 times 35.45. And then I would add 55.85 to that to get 162.2. And let's see. There we go. C. Molar mass is differentiated from molecular mass in that it is measured in grams. Molecular mass would be measured in AMUs. In chemistry, a mole of substance is equal to 6.02 times 10 to the 23rd particles. Absolutely. Sometimes 30 grams. It could be, but the answer is A. That is always the Avogadro's number of particles. It says calculate the molar mass for each of the following to 2 decimal places. So this is sugar. So we have C12, that means we have 12 carbons. Carbon is 12.01. I have 22 hydrogens. Hydrogen is 1.01. And I have 11 sugars, or oxygens. Oxygen is 16. So I have 12 times 12.01 is 144.12. 22 times 1.01 is 22.22. And then I have 11 times 16, 176. When I add all those together, I get 342.34 grams per mole. Aluminum sulfate. Aluminum means I have 2 times aluminum. Aluminum is 26.98. I have 3 sulfurs. Sulfur is 32.07. And I have 3 times 4, 12 oxygens. Oxygen is 16. So 2 times 26.98 is 53.96. 3 times 32.07, 96.21. And then I have 12 times 16, 192. When I add all of those together, I get, so it's on my 192 plus 53.96 plus 96.21, I get 342.17. That's kind of interesting because these two molecules, actually this is an ionic compound, this is a molecule, but they both of these compounds have a very similar molar mass. All right, next question. It says I have a 22.4 liter sample of which of the following substances at standard temperature and pressure would contain 6.02 times 10 to the 23rd. Well, this is 1 mole, and this is 1 mole. Well, in order to have a sample, this has to be a gas. So which of these is a gas at standard temperature and pressure? Sulfur is a solid yellow, so is gold. Cesium iodide is an ionic compound. So helium is the only substance that would be a gas at standard temperature and pressure. How many molecules are in 6.03 moles of CO2? Well, 6.03 moles of anything, there's going to be 6.02 times 10 to the 23rd molecules of CO2 for every mole of CO2. My moles of CO2 divide out. My unit is molecules, and molecules of CO2. So I have 6.03 times 6.02 is 36.3. So I said 3 significant figures. I have 36.3 times 10 to the 23rd, and I'm going to show you in case you don't have a calculator that does exponents. And I know that I would move the decimal over, so I'd get 3.63 times 10 to the 24th. Because when I move this over, I add 1, and I get 3.63. And I knew to round it to 3 significant figures because that's in my problem. How many moles of iron atoms are in this many atoms? So if I have 8.74 times 10 to the 24th atoms of iron, I know that 1 mole of iron has Avogadro's number of representative particles, or 6.02 times 10 to the 23rd atoms of iron. My atoms of divide out, all right? So I have, and I'm going to pretend that I don't have a fancy calculator. I'm going to say 8.74 divided by 6.02. And I know I need 3 significant figures, so that's 1.45. And then I have 10 to the 24th divided by 10 to the 23rd is just 10. All right, moles of iron. Now, since this is just 1.45 times 10, I would accept this answer, or you could say 14.5 moles of iron. Either answer would be acceptable. All right, so that's page 1 of our review.